So we're building a prototype. This is a brand new algorithm. There's so many questions to be answered. We want to make sure we figure that all out before we spend time on really polishing it, making it production quality. Right now, we're in the process of kind of finalizing that prototype. And just today, we had a earlier iteration of that prototype that reached a point where we were able to launch this commit of Leap on a multi-node test network distributed across nodes in different places, right? Like all across the world, all across the globe. So we can have a realistic test of how long it takes to move things around.
Hello, everyone. So this is the demonstration of the testnet launch for instant finality. Currently, we have 21 block producers split on 3 different nodes. These are the nodes at the top here, like each of them essentially represents one machine that has 7 block producers. And then we have 3 P2P nodes that are the canary nodes for these block producer nodes. 1 pair in New York, 1 pair in Frankfurt, Germany, and another pair in Bangalore, India. So we have 1 pair on each continent. Here we go. So now we're producing. Everyone is receiving the blocks as expected.
Instant finality is a name we're giving to this new consensus algorithm. Antelope, an earlier EOSIO, have this consensus algorithm that determines, given a set of signers, which could be anyone, but the way we use it is the BPs. They're participating in according to the algorithm to provide signatures on blocks to determine what the last irreversible block is, which means the blockchain up to that point you can consider final, and it's not going to be reverted, right? You can, whatever side effects happen up to that point, they will remain the same and it won't change. Right now, with the existing algorithm, the time to finality is like 3 minutes, the true time to finality. And what instant finality does is it gives us that, faster, 1 or 2 seconds and you're good time expectation that people have, and actually gives the algorithm that guarantees that that's safe. We're now at the point where we've activated the protocol feature, we've deployed the new system contract so that we can call this set finalized transaction. Okay, now is the time to do the switchover.
And there we go. We are now running instant finality. And as you can see, lib is trailing 2 to 3 blocks behind head.
It's working, and we've transitioned to instant finality. Instant finality is advancing, and the messages across this global network are moving fast enough to complete each stage of the process in less than half a second. But there's 3 stages, so that adds up to 1.5 seconds, basically. And you can see there's the LIB is 3 blocks behind the head block. The blocks have to be sent from one BP to the other, and as we've shown here, it's going through their canary node to the canary node of another BP, which could be in a different region, right, somewhere else in the world, to their BP. It has to go through those hops to receive the block, and then when it receives the block, it votes. The votes have to go back to the leader BP so that they can collect it to a QC and then propose a new block that it captures that QC and advances to the next stage of instant finality. So if that process happens fast enough, then the bottleneck here is really just how quickly we produce blocks to advance things. So if it takes less than half a second to do that round trip, then every block we get another stage, and we have 3 stages. So with 3 blocks, you get instant finality. In theory, though, network latencies or issues can delay that. So you might skip it on 1 block. And in that case, it could take longer than 3 blocks. It could take multiple blocks. But we're seeing here that even in a distributed network across the world, we're consistently getting at most 3 blocks, so 1.5 seconds finality. Tremendous work by the team. They've done such a great job. It's been a remarkable amount of work that was needed. It's just surprising how much work is needed. Yeah, we're finally seeing the light at the end of the tunnel now.